Okay, so we are, I guess, getting close to wrapping things up. We're not, I mean, it's not going to happen this week, but we probably have maybe a chapter and a half left, and then all the fun starts. That fun would be review, until we eventually take the test in May 8th, May 9th. Anybody know? I should know. I don't know. It's on a Tuesday. Yeah, in the morning. It's fun. Exciting. So we're going to talk about logarithmic, exponential, and other transcendental functions. Doesn't that sound fun? Shucks. It's going to be a blast. You got a $20 bill? $20 bill.
I wish.
Anybody have a 20? Good. All right, hold on. I'll get back to you later. I'm gonna need that 20. All right. So what are we going to do? We are going to talk about natural logs. We're going to talk about the number e. We're going to do some derivatives. We're going to get started right away.
No jokes.
I'm not messing around. There's
Oh,
stuff
okay.
to do today. No joke. Oh, did you want one?
Yeah, sure.
Okay, sorry. We're going to find the derivatives of natural log. And then for today, make sure that you...
You got it.
that you don't trip going down the stairs.
That's a good one.
Okay? Wow. Or going up the stairs, which is sometimes worse.
Oh, let's climb up the stairs 2 steps at a time.
Oh, okay, there you go. At least once today, when you go up the stairs, skip a stair all the way up.
I did that all
That's your challenge.
I go up.
Then you have a free It's like a joke. Escalator breaks the All right, I know it's been a while, I apologize, but let's get right at it. Solve that, please. Feel free to use your neighbors, or copy off your neighbors.
Alright, Jeff, this is all on you, but you don't get the wrong place. Oh, you're You don't vaccinate your kids because you know it's going to take them
That's a good start, it's been a while. Because execution it's like that. Not a bad idea.
Oh, it's just the derivative.
You had one not to try one. Negative 1 plus 1 is not negative 2. That's right. So what's why would you get
It's going to be a long day.
All right. I found about 4 answers. So who got one? Nobody got one? No, you got one. Tell us why.
Because you simplify that out so it's x to the -1 power,
Uh-huh.
and then you take the antiderivative of that, so you add 1 to the exponent, which makes the exponent 0,
Good?
and then x to the 0 is just 1.
Perfect, except you forgot one small thing.
It's negative.
What about the coefficient in front?
Yes.
It's just negative.
Are you sure? Okay, other answers. Who got 0? How? One of you, I don't care. Go ahead.
Like you need to get 1 plus would be 1 minus 0. So to subtract the, I don't know.
Be 1 minus
1 minus 1, yes.
0. Okay. Any other answers?
Yeah, that's what
Who
I'm
couldn't
saying.
do it? Why not?
I don't know.
Well, you guys win. That's the correct answer. Okay, so here's the big question. Why does this integral not exist?
Because it's being divided by 0.
Be more specific.
Like when you take the antiderivative, it's always 0.
Again, I hate pronouns. What's it?
X.
Maybe.
The answer.
Okay, so what Nolan explained was perfect for that portion of the antiderivative. But when you take the antiderivative, you also have a coefficient, right? That x to the negative 1, when you take the antiderivative of x to the negative 1, you get x to the 0, which is 1. But you forgot the coefficient. So what happens? How do you take the coefficient? For instance, I know it's been a while, but what's the antiderivative of x squared?
2/3 x to the cube.
1/3 x.
Yeah.
Has it been that long?
1/3 x cube.
Okay, what's that equal to? Good. Raise the power by 1, multiply by the reciprocal of that power. So this would become 1/3 x cubed
plus C.
plus c. Very nice. Okay, over here. So Nolan said he's going to rewrite this as x to the negative 1 dx. No problems there, correct? Raise that to 1, you get x to the 0, which should be 1. But the new coefficient becomes 0. Yeah, that's a problem. Hence the reason we get a DNE. Everybody good with that? Okay, now take out your calculators and FN int the snot out of that bad boy.
Would it be
I got an actual answer.
Uh-oh.
Just x over value.
Uh-oh. Hold on. Okay, so here we have a problem. According to what we already know about taking antiderivatives, we should not get a value because you can't divide anything by 0.
Yeah.
However, your calculator is telling you it's an answer. What is it?
1.386.
Everybody got the same value?
Yeah.
Okay. Let's stop that for a second and go back to when we first started talking about definite integrals. What does that integral represent?
Area.
Area under the curve from where to where? 1 to 4 for the function 1 over x. Graph 1 over x on your calculator. You should probably know what that looks like, but just in case. And you can just zoom 6 or whatever the regular is. Is there an area under the curve between that picture and the x-axis?
Yeah.
Is the answer positive or negative? Positive. Is it reasonable to get an answer of 1 point, whatever you said before, 38, whatever that number was?
Yes. Sure.
Okay, so now do you understand the problem that we have? The picture, by the way, I think I have the picture here. There's the picture. The picture tells us we should get a numerical value. The calculator tells us we have a numerical value. The math tells us there is no such answer. What do we do? Which one's right? Which one's wrong? They're both right or both wrong? Both. Neither
Both right.
You're both wrong.
or both wrong?
There's another way to map it out.
Well, there is. Okay. So, what happens is when you try to do that, we get that conflict there. We should get a numerical value, but the math doesn't allow us. So what someone did, probably Newton, they created a whole new function, and that's where the natural log comes from. So we get that definition. That's where the natural log comes from. And I know you've worked with the natural log before. I know you've done all kinds of stuff with it. We've used it a little bit in this class. You know all the properties and everything. But that's actually where it comes from. The natural log of some number represents the area under the curve from 1 to that value. So for instance, if you take the natural log of 4, go ahead, that was a hint. Take the natural log of 4, I should have said. What do you get? 1.386, which sounds familiar. That's the same number you should have gotten when you fn into the function. So what happens in calculus is there are mathematical concepts and ideas that you've been using for quite a while, but it's not until you get to calculus that you all of a sudden start to understand where these things come from. Something simple like, where does the surface area of a sphere come from? It's derived from the volume of a sphere by using calculus. Oh, we're not going to be doing calculus in a freshman geometry class, so we just give you these magic formulas and say, here, go play with these. Same thing is true with the natural law. Okay, I almost guarantee no one ever explained that to you. Is that an accurate statement? Yeah, they just said, oh, here's this natural log, it does all kinds of fun things. Well, now you know where it comes from. Okay? Problems? Simple concept? Okay. So that's the graph of the natural log, which you've seen before. Notice it passes through the point 1, 0. And then there's some other stuff on there which you can tell from the graph. Its domain is 0 to infinity. What happens if you try to take the natural log of 0? Error. Right. So the calculator tells you it's an error. Why? If we go back to that, why would the natural log of 0 give you an error?
Because it's x of greater than 0, not greater than or equal to.
Right, so it restricts it. You can't take the natural log of 0, nor can you take the natural log of a negative number. So if you try to take the natural log of -2, you'll also get an error. That can be seen pretty easily in that graph. There are no values to the left of the y-axis. From a calculus standpoint, what we are interested in is the fact that it's continuous, it's increasing, and it's 1 to 1. It's also concave down. It is asymptotic to the y-axis. What does that mean?
There's an asymptote on the y-axis.
Good, which means what? But, no, I'm sorry. It gets,
Really close.
how close?
Infinity.
Yeah.
Infinitely close. Well said.
Teamwork.
Yeah, good. Air 5. Anyways. Okay, so see, these are some of the properties that you dealt with in pre-calc, and maybe even advanced algebra, that you might want to jot down if you don't remember. We talked about the first one already, from the graph. Now, stop writing for a second. Let's talk about that first one. Why is it 0? Other than the graph tells me it's 0. That graph tells you it's 0, but from calculus, well,
You're taking the integral of 1 and 1, so it's just like there's no width of the rectangle.
right, correct. Okay, and you should remember that even after 2 weeks, is that there's no area there. Okay. The natural log of a product is the sum of the natural logs. And when you did this in pre-calc or advanced algebra, that might have caused some problems, whether it was remembering that or understanding that, but it's unlike a lot of the other things we've done. We've done things like the integral of a product is the product of the, no, bad example, no product rule in integrals. The sum of an integral is the integral of the sums, that kind of stuff. Now notice in natural logs, multiplication becomes addition, division becomes subtraction. And then number 3 is the power rule, which allows you to take that exponent and move it out in front of the natural log. And you kind of remember those, right? Okay, good. All right, so just going through these very quickly, how you can break down natural logs. So 2 things. Can you break down the natural log, can you break down a complex natural log into a series of different natural logs, or can you take a series of natural logs and put them back together into one natural log? Okay, so for instance, if I wanted to solve that problem, I want to know what the natural log of 10/9 is, I can just type it into my calculator. I could also, if for some reason I wanted to break it down into the natural log of 10 minus the natural log of 9, I could do it that way. And just a couple more examples. If it's a square root, you can move the 1/2 out in front. And there we have a combination of a product. I could break that down a little further into something like that. Probably not a lot of what you're going to do, but it might make your life a little bit easier when you're trying to do some complicated integrals. Okay, let's talk about E. You've seen E before, right? You've used E? Yes? Do you know where it comes from? Okay, so we have the same scenario. Does anybody remember what E is? 2 point something? All right, here we go. I'm going to give you an easy way. Has anybody seen this before? Oh, this is beautiful. Okay, so this is how you can remember E. This is a $20 bill. Who's on the $20 bill? Okay, hold on, let me keep up with myself. That's a $20 bill. Andrew Jackson's on the $20 bill. Do you know what president he was? He was the 7th president. Do you know when he was elected? 1828, correct. Did you know also that he ran for 2 terms? You with me so far? I know it would be 1832, but shut up. Then we do some fancy origami here. Give me a second here.
That's exposed the Illuminati.
He'll see. Okay, so if you fold the $20 bill into one of these, what is that? Kind of triangle?
Right.
A right isosceles triangle, also known as a
45,
45, 90, excellent. Or it could be a 45, 90, 45 triangle, couldn't it?
Oh no.
There's E. Now, if you type E into your calculator, which would be a good thing to do, find the E button on your calculator. There's 2 of them, depending on how saucy you're feeling. There's plain old E, or there's E to the X, whichever one you want to use. Okay, depending on whether or not you're raising E to a power. What happens when you type it into your calculator? You get 2.71828182846. Right? Because it rounds to 10 decimal places.
Stop it.
Mine stops
Stops at second 2.8.
Oh, really?
Yeah.
Oh. I guess you guys bought cheap calculators. We'll get into them. But that's E. Just a cute little nerdy, geeky thing to remember E. All right, but where does E come from? And you have no clue, right? So my question is, when you've seen E before, and this might be a hard question to answer, in what context did you use E? Do you remember? How so? I mean, I'm not being critical. I don't know where E would come into play if you're not doing the calculus. It's been many years since I've taught advanced algebra.
We did have word problems. So
Is
you
it-
had to use like velocity.
If the natural log of E is 1, right? Try it. If this is right on the top wall.
Yeah, it is.
Woo-hoo! So the natural log of E is 1. Okay, wait, hold on. Let's use that. If the natural log of E is 1, where does E come from? Because we defined the natural log already, didn't we?
Integral of 1 over x.
Say again?
Integral of 1 over x.
Integral of 1 over x. So if the natural log of E is 1, where does E come from? Maybe you want to sketch a picture? Maybe this will help? There's a picture for you. Or maybe this will help. Whoops, no, sorry. Clicky happy. There. So if the natural log of e is 1, how does that apply here? Anna?
We used to have E in for X.
Okay, so we put e in for x. I get you. The natural log of e would be the integral from 1 to e of 1 over x. Right?
Yes.
So, and we know from what Paul did, I just had a brain fart there, that the answer is 1. So how does that relate to that? What does it mean? Eli?
The area under the curve from e to 1 for 1 over x is equal to 1. Like e is where the interval, where the area under the curve is equal to 1.
Couldn't have said it better. You follow that? You can say no.
Can you repeat that?
Could you repeat it or explain it again?
So e is like the spot on the interval to find like where the area under the curve on that interval is equal to 1. I jumped into this.
Yes?
Yeah.
Okay, so what he's saying is, he said it very well, but I'll explain it again. If you come out here to 2.718281828459045 E, then the area under the curve equals 1. That's it. It's that special number that gives you an area of 1. Now, why 1? I have no idea. I don't know why everybody's so obsessed with the area being 1, but it gets us this number e that we can work with. Okay, where did we leave off? I'll skip all this stuff. Yep. Okay, so there it is. Well done, Eli. So what can we do with those things? Well, this is calculus. Now that we know where they come from, we can do all kinds of fun things. There's the definition. We knew that already. We've done enough of this. I just want to make sure you know how to use your calculator. We talk. Oh, well, I guess I didn't ask that. Why would the natural log of 0.1 be negative?
Because you're going from 1 to 0.1,
Yep. And therefore?
therefore the area would be negative because you're going backwards.
Good. So remember that rule that if the upper limit of integration is smaller than the lower limit, then you flip the two and put a minus sign in front of it. Okay, so if you're taking values that are greater than 1, you'll get positive answers. If you're taking values less than 1 but greater than 0, because again we can't take the natural log of negative numbers, we'll get a negative answer. And also, one other reason is if you go back to the picture, notice that we're below the x-axis there. All right. One of the things that the natural log does for us, and that we're going to use, is something called logarithmic differentiation. Okay, and we'll get to that in a second. But what we want to do, because this is calculus, we'd like to know how to take the derivative of that thing. And so if we've taken the integral of 1 over x to equal the natural log, then if you take the derivative of both sides, you get number 1. And the derivative of the natural log is 1 over x. Real easy. However, number 2 is what we're going to use more frequently because it will apply to all functions. Notice that in number 1, we're just looking at a simple function of x. In number 2, we can look at more complex functions. All that's happening between 1 and 2 is we're just doing a little chain rule there to get that. But the easiest way to do this is just remember that u prime over u. You're going to do that over and over and over again. So that would be flashcard material if you're a flashcard person. The derivative of the natural log of u is u prime over u. So when we're doing problems, when we look at the next example, I'm going to say that over and over again, u prime over u prime over u, so eventually it'll burn into your melon. And if it is just 1 over x, you can still use u prime over u, it'll just simplify quite a bit. Okay, we good? So what's that? Say again? Nope. What's u?
Oh, right.
2x. What's u prime? 2. So therefore, 1 over x. Right. This is a weird one that simplifies to what we already knew, which is 1 over x. And again, don't overthink this. U prime over u. Identify u, take the derivative of it, put the derivative over the original function, simplify, good to go. Okay, what's that? What's the derivative of the natural log of x squared plus 1? Sam, what's u?
X squared plus 1.
What's u prime?
2x.
Therefore,
X squared plus 1 over 2x. No, 2x over x squared plus 1.
and then the x's just cancel, right?
No.
You sure?
Yeah.
Can't just cancel the x's here?
No, you cannot.
Are you sure?
Pretty sure.
Pretty sure?
Yeah.
AT test sure?
Yeah.
You're staying with your answer. I can't talk you into canceling those x's.
Yep.
Good job, Sam. Oof. Product rule. 2 functions going on there. Notice you've got x and natural log of x. Derivative, or the first time's the derivative of the second, plus the second time's the derivative of the first. Derivative of natural log of x is u prime over u, which is 1 over x. And we end up with that monstrosity. 1 plus the natural log of x. Now the reason I included that one is because I wanted you to recognize that as a product rule. That's not just a u prime over u. Remember, u prime over u only works for when you have a natural log of some stuff. How can we make it more complicated? Sorry, more interesting. Some trig would be fun.
Absolute value.
Absolute value would be awesome.
Why do you guys hate yourself?
Anything else? Square root. What if we combined all 3? Yeah, just kidding. I just got that. That's not really exciting. That's just a, you know, that's just a plain old power rule. Actually, that's a chain rule with a power rule. Bring the 3 down, reduce it by 1. Take the derivative of what's inside. We end up with that. Like trig, you have to take the natural log of something. So if you have the natural log of x over x, the x's don't cancel and you just have natural log sitting there. Don't do that, please. That'll get you a come on, man. Now we're going to talk a little bit about the natural log or logarithmic differentiation. This will be fun.
That is solar.
What's that?
Is that solar?
Uh-huh. Can you name all those things?
No. I'm just recognize that.
That's the only one on there
Recognize more than
that
this.
I think I can name maybe most of them, if not all of them.
Let's hear it.
Do it.
Well, in the top are the Tetris blocks. Then you've got Green Lantern's ring. Then you've got the One Ring. You've got a Pokemon ball. That's a Dark Knight boomerang. That's the cricket from Men in Black. That's a green turtle shell from Mario Kart. That's the gun from Man with the Golden Gun. That's a phaser from Star Trek. That's a bomb that could be pretty much to anything, but I would assume that's from maybe some type of Nintendo game. That's a silenced gun from GoldenEye. That's the knife from Prince of Persia. Those are the dual guns from Tomb Raider games. I don't know what that weird gun is there. The whip is from Indiana Jones. I don't know what that one next to it is. We all know the Infinity Gauntlet now. I don't know what that, that's Freddy Krueger's glove. I'm not sure about the sword next to that. That's a hammer from Nintendo again. The sword next to that, I believe, is, I don't know what that sword is. Thor's hammer. I don't know what that black circle is either.
Isn't that the Winter Soldier?
No.
No.
Yeah, it doesn't have a shield.
That's a gun from Halo. That's, I don't know what that tank is from.
Just skipping over the Half-Life crowbar? Come on, man.
What's that?
The crowbar from Half-Life?
Yeah.
Well, I'm getting there. Oh, where's the crowbar? Oh, I missed the crowbar. Sorry, I knew that was from Half-Life. Those are the Teenage Mutant Ninja Turtle swords. Those are lightsabers, obviously. I don't know what that baton is in there. Is that a portal gun?
Yeah, is it the wooden one like a cricket? What was that?
That's a cricket bat, which would probably from Shaun of the Dead.
Yeah, that.
Yeah. I don't know the gun on the,
Is that
in the
from
middle.
Portal 1?
I know the Teenage Mutant Ninja Turtles.
The chainsaw could be from just about anything.
Portals 1 and 2.
I'm guessing probably from Evil Dead.
Yeah, Evil Dead.
That's a Thundercat sword. I don't know the sword all the way to the left.
Making this up.
No, I'm not making those up. That's Aragorn's sword from Lord of the Rings. That, I believe, is a Zelda sword next to that, right?
Yeah.
Those are God of War swords as a Ghostbuster pack. That's Cloud's sword from Final Fantasy VII. That's Zelda's shield. That's a Gears of War gun. The katana could be anybody, probably, what's her name? Beatrice from Kill Bill. The gun sword is from Final Fantasy VIII. The other sword on the left is Soul Calibur. And then the one on the right, I'm not 100% sure, but I think it would be from Alien. Or Aliens.
Yeah.
The guns that the Marines carry. So the one I don't know is, or a couple that I don't know is a sword all the way to the left. It's really not something I'm proud of.
What's your most played?
I don't know that one, I don't know that one, and I don't know that one.
What's your most?
Oh, no, there's a portal gun, so that can't be a portal gun.
Didn't they have a different gun or Portal 1?
Isn't that the object where you like move things around?
This? From Half-Life?
No, Gary's mod.
Yeah, but it's still, it originated from Half-Life. And I don't know what that is, what shield that is.
What's the game that you played the most?
The game that I put the most amount of time in, Diablo 3.
Is that the new one?
Well, new, I mean, it's still like a 4-year-old game.
Oh, didn't they like mess up with Diablo? Like the whole community was.
Yeah, we don't need to talk about that now.
I just saw it on Reddit.
It's
like, yeah,
Okay, so we'd like to find the derivative of this monster. And hopefully you all recognize that this is insane. Why would we take the derivative of that thing? This is one of those where you think about all your other options. Crying, not doing it, cheating off your neighbor, looking up the answer in the back of the book. Praying, I forgot praying. Calc check. So if and when we take the derivative of this, hopefully you would recognize that we have a quotient rule with a chain rule, with two chain rules. And it's going to be nasty. Okay. Therefore, we can use this new thing called logarithmic differentiation. It's tricky, but it's easier than applying to it. Now, are you going to start using logarithmic differentiation for all your derivatives? Absolutely not. But if it gets big and scary like this, you would definitely use it. And it goes like this. Number one, you take the natural log of both sides. Basic law of algebra, whatever you do to one side of the equation, you also do to the other side of the equation. Number two, use log properties to simplify the more complex side. Oh, I forgot to mention, then you differentiate. You take the derivative of both sides. And then solve for y prime. Lo and behold, you have the derivative. All right, here we go. Are we good? All right, I'll take that as a yes. All right, so take the natural log of both sides. Simplify the more complicated side. So I can just write an equal sign. I can write this as the natural log of x minus 2 quantity squared minus the natural log of the square root of x squared plus 1. Okay so far? If I lose you along the way, just holler. This is the same thing as 2 times the natural log of x minus 2, sorry, and this is minus 1/2 times the natural log of x squared plus 1. Be careful with parentheses in a problem like this. Make sure that the thing you're taking the natural log of stays in parentheses. Okay, we good so far? Next part. Take the derivative of both sides. So what's the derivative of the natural log of y? What's the natural log, what's the derivative of the natural log of smiley face?
1 over smiley face.
Hmm?
1 over smiley face.
Not quite. Smiley face prime over smiley face. So what's the derivative of the natural log of y?
Y prime over.
Y prime over y. Ooh, I don't know how that happened. Y prime over y. Okay, what's the derivative of the natural log of x minus 2? 1 over x minus 2. But we also have a 2 out in front, so we'll do 2 over x minus 2. Cancel the 2's here, right?
No.
Just checking. What's the derivative of the natural log of x squared plus 1?
2x over x.
Yeah, we just did this before. 1/2 times 2x over x squared plus 1. Let me clean that up a little bit. Y prime over y is equal to 2 over x minus 2 minus 2 x over x squared plus 1. Almost done. Our goal here is to solve for y prime. So I'm going to move this y over to the other side. Equals. No, I don't want to do an equal there. That's sloppy math. Hold on. Y prime is equal to 2 over x minus 2 minus x over x squared plus 1. All of that times y. Ooh, that's fun. Oh, but wait. What's y?
The equation.
Yeah, the original equation we started with. So therefore, just to keep things above board, oh, relax. Y prime is equal to 2 over x minus 2 minus x over x squared plus 1, all of that times what we started with, x minus 2 quantity squared, I don't know what just happened, over the square root of x squared plus 1. No, you don't need to simplify that, unless something's very obvious. No, you don't need to combine the terms inside the parentheses. Just leave it like that. That seems like a lot of work. However, if you did it the other way, I think you would see how nasty it would be if you went back to the method that we already know, with a product rule and a quotient rule and all these other chain rules involved. This approach, I think, is much easier. So, how are you going to know when to do logarithmic differentiation? 99% of the time, the problem will say, use logarithmic differentiation to find the derivative of blah, blah, blah. Okay. And if we stay with that process or that mindset, we'll be fine. Just keep doing what it is you need to do until it tells you to logarithmically differentiate. Questions on that process? We're good? Okay. Absolute value, somebody mentioned absolute value earlier, right? There's nothing to do with absolute value. It doesn't matter. If you're taking the absolute value, or taking the derivative of the natural log of the absolute value of something, the absolute value just washes out. Why?
Because you can't take the
Say that again.
You can't take the negative numbers. So that
Be more specific. You can't.
take the.
You can't take natural log of
So because there's no negative values that you can take the natural log of, then absolute value becomes moot. It doesn't affect the outcome anymore. Okay. So, last one. What's that? Cosine prime x over cosine. What's the derivative of cosine? Negative sign?
Yeah.
Positive sign? Negative? Are you sure? Yeah. Let's see what the clicker says. Yeah, it's negative. Good job. Which, again, look at the last step there. If you're feeling all fancies in your panties, you can simplify it a little bit more. Nailed it! Have a great day, everybody. Yeah, next day. On the calendar. Anybody get the joke? Those are natural logs, yeah. Shut up. Yeah. Oh, yeah. Jeez. Forgot about that. Sorry, Nolan. My bad. My B, yo. That's what the kids these days say.
Right on.
Every time I do this, I'm at about a 50% rate, where most of 50% of people just walk out of the room without anything.
Wow, that's not very sweet.
I'm gonna grind it out there. Food on the table.
Then you could have a long term.
Hi.
Hello, I have a study hall in this period, it says.
Yeah, I'm not sure if they're staying in here or moving, so come on in and hang out.
Alright, well, it just says it in this class, so.
Okay, so yeah, you can hang out until, I'm sure more people are gonna start rolling in.
So I think we're gonna move, so don't get too comfortable. I think there's another room that we're probably gonna use for the semester, but you can hang out here for now.
Can I leave my stuff in here, Mr. Grassi? Is that cool? Gracias.
Probably gonna move, so have a seat, but I wouldn't have that, so I'm hoping we're not. If I read the schedule right, I know there's a room open.
All around in a circle looking for 338. I was like, where is this room? And then I'm like, oh! This is study hall, right?
Study.
Yeah, good.
Hey, I missed you too. Nate, I lost you for good. So I think we're gonna move, but so to a different room for the semester, but hang out for now. We'll see. Oh, come on in. Welcome.
Where's the hat? And I'm like, one possible and has to be a super. I'm like,
I have to go to school. This
I'm not getting no. This guy. This Canadian over here. She got that whole for by the top. Why is your this is my Right, Canadian? Sure, Dominican. Should be like,
All right, good afternoon, everybody. I'm Mr. Grassi. We are going to move to a regular classroom. I think we'll get more done. We're going that way about 5 classrooms to room 333. I know. Yeah, finally you find where it is. We're not far. That was
what happened was I came up over there and I decided to go around. Now I have to go.
Looking for me? 3:30?
Yeah, I gotta go shopping after school, but close to that, yeah.
3:35?
Again, I gotta go shopping after school. I don't know how long that's gonna
What are
take.
you shopping for?
Art project?
Yeah, I know. I'm saying, where do you have to go, like Joanne Fabrics or something?
I'm going to Michael's. I like Michael's.
Because it's your name?
That too, but it's also that it's not Hobby Lobby. Give those.
I like Joanne Fabrics.
Joanne Fabrics is good.
All right, see ya.
Yeah. You free 7th this semester?
Huh?
Hi.
Hello, how are you?
Good, how are you?
Good.
Is it the same seat?
I didn't hear you, sorry.
Is it the same seat?
You're actually gonna end up moving, but if you want to just go to your seat now, we'll move all from a big happy family.
Like a sign? I didn't know someone was waiting for us.
How are you?
No.
This it?
What's up?
This it? This is our class now. 6 people.
Hi.
You're running late. Shut up. What do you have lunch?
I got moved to this new couch this class. I was got this before.
Mr. Reedy.
Hello, how you doing?
What's running?
Where do I?
Wherever you want. We're gonna move anyway.
We're moving anyways.
Paige, how are you? What you drink, sister? Uh-oh, that'll
No,
be
we're
good.
moving.
Hello.
Are we?
Hi.
You're the enemy. Tengus. Tengus.
Yes.
Are you still in 7?
No. Third.
Everyone's gone.
Yeah, I know.
Only one person here. Another 12 people here.
There he is. Imagine yo Evan. If it's not me and Bachi, what you do?
Hi, everybody. Hi, everybody. How are we? So, very nice. Yours? So we have a new person that's
Dylan.
Hey, everybody, Dylan. Dylan, this is everybody. Who did we lose?
Brennan.
Susanna.
I'm ready.
Brennan's right over there.
Never mind.
Anybody else? Did we lose Logan?
Him and Dan are snuggling out with the drinking.
Oh, that's good.
Slumber party.
Is she still in the class, you know? You wasn't your turn to watch her?
She has I think she's on crutches, so maybe she's gonna be.
Step on a landmine or something, or?
Probably.
Lose the leg, or just?
I don't know.
I mean, did you see her?
I kind of saw.
Did she have the leg still attached?
Probably.
Oh, then she's probably okay. Sprained ankle. Okay, with the start of a new semester, let's make things interesting. You need to find a new seat. However, you cannot sit at the same table, nor can you sit with the same people.
What do you mean?
Now, all 4 people cannot be the same. You can throw somebody out if you want to move to a different group, but it's up to you. Go quickly.
We have a woman. Yeah, she's also a woman. No, but it's not.
Sit at the end.
The real reason I was going.
You're at a desk. You're fine there.
I was a C.
But that's okay. It's not the same 4. As long as you're on 4 same people. Who's missing from your 4? Where's our boy? Seriously, where is he? Does anybody know?
No, he told you he switched.
He did? How did I react? Was I upset or was like, yeah?
He was really happy.
Oh, good. I was honest with you. Excellent. Okay. How was everybody's break? Good. Any good stories that don't involve the police? No? Dylan, where are you coming from? No, I know that. Are you Grassy or Helene, or are you dropping down? Were you 90s or 80s?
80 still.
Grassy or Helene?
Yeah, Helene. I was in calculus.
Yeah. You had her 5th period?
Yes.
So now you moved to 6th.
No.
Welcome. We got about a chapter and a half left, and then we start reviewing for the I almost said final, for the AP test, which is in May sometime, first week in May, I think. So we're going to get after it right away. So take out some notes. Let's go. We will probably not have time in class today, but tomorrow we will restructure our Treat Tuesday. No, it'll be Treat Tuesday still. We'll just skip that week, and then next week we'll make sure that next week is somebody who we can trust to bring in just like a bang up job instead of 1 bag of Oreos and half of the free stuff. Dylan, we do Treat Tuesdays in here. That means that you'll find a partner, and you and that partner will bring in a snack and a drink for everybody once. We only did once, right? Yeah. So it works out that you have to bring it like once per semester. So every Tuesday we have a little snack and a little drink. Usually Capri Suns, which is kind of a problem because Brendan has an issue with Capri Suns. We're trying to get into a 12-step program, but not for hours. Okay, so doesn't it sound exciting? Logarithmic, exponential, and other transcendental functions. This is going to be fun. It works better when you turn it on. All right. Talk a little bit about the natural log function. Almost everything that we're going to talk about today, you've already been exposed to. You just don't know where they come from. In other words, we're going to talk about the natural log. You've seen the natural log before. You've used the natural log before. Probably no one ever explained to you where the natural log comes from. They just said, here's a natural log, go use it. And there's a couple examples of that in this lesson. So we're going to talk about natural log properties. You did that in pre-calc. We're going to talk about the number e, and we're going to find the derivative of the natural log function. And I forgot to include a last one on there, so let's say for the rest of the day, anytime you go up the stairs, skip a stair. Joke said like you?
Go 2 when we go down.
Yeah, go 2. So skip 1 would be 2.
I call it one.
You what?
I call it one.
So 2 would fix the problem?
Probably, yeah.
Jacob?
I also do that going down.
I don't think there's an implication that broken bones would occur.
They're gonna fall down the stairs, then.
Yeah, if you're going like down the stairs and flash through this.
Well, no, going, I said going up.
It is dangerous.
Is this like one Is what?
This
I don't know. You may have to actually take notes.
That's wrong.
All right, let's start with a simple problem. It's been a while. This will be a good refresher, get you back on track. Solve that problem, please. Remind me before we leave, I have new phone doc numbers for you because we lost Logan and Dylan's new, so we'll move some numbers around. So I'll give your new number to you before you leave. Start. Again, a good start. Better than sitting there staring up at the lights.
You subtract 1.
Wait, I remember.
Right on time.
Click on the button.
Then it's just
Well, you've got three scenarios. They're right. You're right.
Oh, yes.
Four scenarios.
That's 1 over here.
Oh, he got 1.
It's either in the front or the 1. Then you
got negative 1. What are we going with? 0. What do you guys got? You say it was 5? 5 different answers. This is a problem. I think we're looking right now at 4 different answers. Here's one thing I do know. They all can't be right. So let's talk about our possible answers. Let's start over there. Why 1?
Because I rewrote it, so I did x to the -1.
Uh-huh.
And then
That's a good start.
To get the antiderivative, you add 1 to
Beautiful.
the exponent, and so then you get x to the 0, which is 1.
Excellent. Everybody follow that?
Yes.
This is the same thing as the integral from 1 to 4 of x to the negative 1 dx. So therefore, we get, that's raise it by 1 would be x to the 0, which is equal to 1. Not bad. Things.
For the antiderivative, we got negative 2/3 x raised to the negative 3/2.
Negative 2/3 times x raised to the negative 3/2. Okay, so if that's your answer, if I take the derivative of this, I should get 1 over x. I don't.
You don't?
No, because I would get x to the negative 5/2. Yeah, so we're going to cross that one out. Somebody else had, you guys had what, 1? 0 was another answer. Where's my zeros at? That was you guys.
We should be had 0.
You had 0?
No, now we have 0.
Now you have 0. How'd you get 0?
Okay, so since you converted to x to the negative first,
Yeah, I got that.
yeah, add on x equals 0, but you have to multiply by the reciprocal, and 0.
Oh, whoa. Hold on. Let's, quick review, kids. If we take the antiderivative of x squared, what do we get?
1/3 x cubed.
1/3 x cubed. I know it's been 2 weeks, but as a quick refresher there. Raise the exponent by 1, multiplied by the reciprocal of the new exponent. Yes?
I agree that it's 0, but I don't think it's the same way as what you're saying. Because wouldn't it be x to the 0 from 1 to 4?
Okay, we're back.
Yes,
We're back.
but if you don't have anywhere to plug the numbers in, then you
Wouldn't
just...
it be 4 to the 0, which would be 1, minus 1 to the 0, which would be 1. You know what I'm saying?
If I understand what you're saying correctly, you put in a 4 there. 4 to the 0 is 1. Minus...
We're back.
Minus 1 to the 0, which is 1. 1 minus 1 is 0.
Yeah.
Perfect.
Yes.
All right, there's another possibility.
No, we're back to 0.
Now we're back to D&E.
D&E.
It is D&E.
Yeah, we're back to D.
Back to D&E?
We're back to D&E.
All right, go.
So, if you're taking the antiderivative, you add 1 to negative 1, so that gives you 0.
Got
And then
it.
you have to take the reciprocal of 0,
Which is?
DNE.
1 over 0.
1 over 0.
Yes.
Which you can't.
Boom!
Oh.
Yeah.
Okay, so we've seen 3 possibilities. Did I miss any? Any other answers? So we've seen 3 possibilities. Any of you that have... I don't want to... Hold on, let me think about what I'm going to say before I give it away. Any of you want to change your answers now that you've seen these discussions? You're going to fight for your 0, your 1, or your DNE?
It was like a step that you already but it wasn't.
You're changing to DNE.
Because I didn't realize that the others.
Okay, good.
We're sticking with negative 2/3.
Excellent. Good. Stay in or change it?
Changing to DNE.
DNE. It is DNE. Great. So, Evan, did you explain this?
Yeah.
So Evan's explanation is perfect. Now, some of you are on the right track that you would get x to the 0, which is 1, and you could get 1 or 0 depending on how you plugged it in. The thing that screws up the process is we forgot to take the reciprocal of the exponent to get the coefficient. So the answer is DNE. All right, get out your calculators.
What is
Using your calculator, FN hit that guy. What? Yeah. All right, hold on. Everybody's telling me the answer is 1.38 something or another?
Yeah.
How is that possible? It isn't. Okay, let's try a different approach. What does that mean?
On the area of.
Ready, go ahead.
Find the area under the curve from 1 to 4.
Good, so graph 1 over x. Standard window, or you could zoom in, whatever you want to do. Just get a picture of that graph. Oh. If you just look at the graph, should we get a value?
Yeah.
Yes. Will that answer be positive or negative? Positive. Positive, because it's above the x-axis. Now we have a huge problem. Your calculator is telling you on 2 different occasions, it's telling you you should get a number which is like 1.38, yada, yada, yada. But the calculus is telling us there's no such thing. Evan,
Wait, can I say why or no?
do you know why?
I think so.
Do tell.
Asymptote?
There is an asymptote in that function, but it's nowhere near the area that we're talking about for 1 to 4. Okay? Anybody else? You understand the problem that we're dealing with, right?
Yeah.
Jacob?
Calculator in the wrong mode.
No, because it's not trig. The only thing that would affect that is if it was trig. Else?
But does it not matter if it's anywhere near our area, because we can't even get the antiderivative of it without even plugging in.
Which is why we're all frustrated. The calculator is telling us we should get an answer of 1.38, blah, 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 blah. The calculus says it's not possible. Impossible. How do we justify that? Or how do we solve the problem? Well, it's simple. You cheat. Yeah, and the cheating comes this way. You say, I can't do that mathematically. But I know I should get an answer, right? Because there's the picture of the graph. I should get an answer of about, well, let's see, if I go from 1 to 4, I go from 1 to 4, that's about, that's 3/4 of a square, maybe, yeah, so that's about 1.38. Just approximated that. How do I do that? We cheat, and we cheat by creating a whole new function. That's where the natural log comes from. So I can't do that mathematically, so instead of being able to do it mathematically, I'm just going to create a new function and call it the natural log. So the natural log is defined as the area under the curve of 1 over x from 1 to some number. And if you understand that, you can answer the following question. When you type into your calculator the natural log of 4, what do you think you're going to get for an answer?
Same thing.
I'll do it. See what you get. Take the natural log of 4. Okay. Now, while you have your calculator in hand, let's talk about a couple others. What's the natural log? Well, don't type it in. Just listen first, and then answer my question. Then type it in to confirm. What would the natural log of 1 be?
0.
Why, Alex?
Because 1 to 1 is a line.
Beautiful. What's the natural log of, let's say, negative point? Sorry, we'll keep it positive. What's the natural log of 0.5?
Negative number.
Why?
Because if 1 to 1 is 0, and like any number less than 1 would be lower than 0, so negative.
Why?
Because it's underneath the x-axis.
What's
Area.
it?
Area.
Hate pronouns.
Sorry.
The area of?
The function.
What you're saying is not false. I'm just making your life difficult by making you explain it better.
So keep going.
Yes.
Oh,
Give us a little bit more.
I don't know, that's like what went through my mind.
Okay.
Come on.
Anybody else? Other than you? Why is the natural, well, do it just to make sure we get the right answer. What's the natural log of 0.5? It is a negative number, right? Okay, so why is it negative? Does everybody understand what Tengus is saying? What is he saying?
I don't know.
Whatever you say.
Go ahead.
So since the greater number has to be on top, you have to flip the function to be negative.
Good. That's one way to look at it. If your upper limit of integration is smaller than your lower limit of integration, you switch the two, put a minus sign out in front. So you'd actually do the integral from 0.5 to 1, get a positive number, and then multiply by a negative number. Graphically, if you look at the function, there's the graph of the natural log function, you can see that the answer is negative because we're looking at a value below the x-axis. On that slide has a bunch of information about the natural log function. You've done this before. It passes through the point 1, 0, because the natural log of 1 is equal to 0. It's increasing, it's continuous, and it's concave down. It's asymptotic at the y-axis. What does that mean?
It doesn't cross.
Doesn't cross, but
Really close.
how close?
Infinite. Really.
Really close, yeah, infinitely close, good. It's asymptotic to the y-axis. There is not a horizontal asymptote for the natural log function. It keeps going up to infinity. It slows down how fast it goes up, but it never does stop going up. Common mistake is people think that it's asymptotic at like 2, but that's not the case. Say again?
That'd be silly.
Yeah, just crazy. Come on. Okay. Now, the rest of the stuff about natural log I think you've done before. So those things. We talked about the natural log of 1 being 0. If you recall, when you deal with logs, when you have the log of a product, that's equal to the sum of the logs. So multiplication becomes addition, division becomes subtraction. And then number 3, if you have an exponent there, you can move the exponent out in front, take it out of that natural log. It's like trig. You have to take the natural log of something. So for instance, if I have the natural log of x over x, the x's don't cancel and you're just left with natural log. That's just insane. That's going to get you a come home man. And you've done this before, right?
Yeah.
You just don't remember it. Yeah, okay, good. Good. Okay, we good? Am I going too fast? All right, so I just have a couple examples here of how you could break these things down. We're going to use this later on, but again, just demonstrating that a quotient becomes a difference. That's the square root is the same thing as raised to the 1/2 power. You can move that out in front. And then the last one is both a product and a quotient that you can simplify. Most of the time you're not going to do that except for the very last thing we're going to talk about today, which is called logarithmic differentiation. You'll need to remember those log properties. Okay, let's talk about E. E is a number. It's like pi. Does anybody know what E is? 2.7 something.
Yeah.
Anybody have a $20 bill?
No. I have a one.
Nobody has a $20 bill? We'll get it.
Yeah.
I'll give it back. Oh, thank you. Okay, beautiful. So I'm going to show you a nerdy way to remember what E is.
That's a crystal. It is crystal.
It is crystal. It's an older one, though. Or is this no, this is a newer one. Mine's an older one. Okay. So here we go. What is this?
Money.
Yes, what kind of money?
Paper money. It's a $20 bill.
Thank you, it's a $20 bill. Who's on the $20 bill? Jackson, it says in letters right there, Jackson. Does anybody know what president he was?
6.
No.
7.
He was the 7th president.
Let's go.
What year was he elected? 1828. Beautiful. How many terms did he run for? 2. 2. And here's the fun part. If you take this $20 bill and do a little bit of origami with it, and tear it in half. Sorry, I got a big sausage. If you do some origami and fold it carefully, you get this. And what is that?
Paper football.
Good.
Triangle.
What kind of triangle?
Equilateral.
What kind of right triangle?
Isosceles.
Isosceles, also known as? You just had like math Tourette's. You just keep shouting out phrases that you think you apply there, right? Square root. What kind of triangle?
36, 45, 45.
No. I'm sorry?
45, 45.
45, 45, 90, also known as a 45, 90, 45, and there's E.
Wow.
What? No. Yeah, how weird is that?
Something.
Question.
We have to memorize all those.
You don't have to memorize anything. This is American. Fight the right eye. Fight the power right eye. Yeah, so if you type in E on your calculator, do so please. There's 2 places you can get E on your calculator. There's an E button, or there's an E to the X button. Feel free to use whichever one you like. But you will see that I think yours, does yours end in 4-6?
No, it ends in 2-8.
Oh, it ends at the, oh boy. It ends at the 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, you're short, no way.
We're all short. Yeah, no.
I don't know. It's crazy. Perfect. Okay, so that's E. You've worked with E before in the past. Now you know what the number is, but the question is, do you know where E comes from? Reverse ln natural log. I just, again, you have to write it.
It's Latin.
Right.
It's Latin.
It's Latin.
It is Latin.
From the Latin word E, which means
Sigma.
Well, before we do that, let's go back to this. What's the natural log of E? You got a calculator, do it. What's the natural log of E?
1.
1. Why is it 1? The E's cancel. Could you be more specific?
Natural log is just log of E.
Log base E?
Yeah.
And the E's just cancel.
Yeah.
Not a bad answer. Based on that equation, y is equal to 1. Or, more importantly, what's the significance of the number E? There's got to be a reason why somebody thought the number 2.7182818459045 was important. Why? So if I plug E into that equation, I get the natural log of E, which we already know is equal to 1. What about the right-hand side of that equation? What is that saying? No, not that far right. To the directly right of the equal sign.
1 over E. The area under 1 to E is E.
Close.
Or the area under 1 to E is 1.
Good. Yeah. Okay. So now we go fast forward here. Look at this picture. The significance of E is that it's the spot on the x-axis that if I go from 1 to the right, when I get to this mysterious number, all of a sudden this area is guaranteed to be exactly 1. And at some point in time, somebody thought that was significant. Well, kind of. It allows us to flip back and forth between natural log and numerical values and canceling natural logs, like the natural log of E is 1 because the E is canceled, that kind of stuff. Okay, but that's where it comes from. Now, without calculus, that wouldn't make any sense. That's also why no one's ever explained it to you that way, because to explain something like that to someone who hasn't had calculus wouldn't make any sense. It's also why, like when you talk about, like a lot of volume formulas are derived from calculus. Where does the surface area of a sphere come from? It comes from the derivative of the volume of a sphere. Or the volume of a sphere comes from the integral of the surface area of a sphere. Well, I'm not going to do calculus with my freshmen in geometry, so they just learn that the surface area of a sphere is 4 pi r squared. Okay? So that's what we get out of that when you plug in E. All right, just to make sure, well, we talked about these, you don't have to do it. Natural log of 2 would be that, natural log of 32 is that, and we talked about why that answer would be negative. What about the natural log of negative 2? Do that, please, on your calculator. What do you get?
Error.
Why?
It's less than 0.
Why?
Because that's the rule of natural law.
Oh, because there's an asymptote.
So?
At 0, and you can't cross it.
Beautiful. Okay. And yes, what you're saying is also true. So if you look back at this formula, where is it? That guy. In the theorem right there, it states that x can't be greater than 0. If you look at the graph, you'll notice that there's no values in the negative region for the natural log graph. Therefore, you can't put in a negative number because there's no numbers there to put in. And we already talked about why the natural log of 0 is undefined. Because again, it's asymptotic, can't have a value. Okay, so we're going to run into some issues, and I have an example for you in a second, where we want to start taking the derivative of the natural log function. Sometimes, well, I shouldn't say it sometimes. Most of the time, this is really easy. I'm going to show you the theorem. Some of you will overcomplicate it, but it's very straightforward, very easy. It can get nastier, though, and we'll do that later when I have a new technique for you. Okay? So, here's the derivative of the natural log. Number 1 is if you just have the basic natural log of x. But we're never going to run it, I shouldn't say never. Seldomly will we run into just the natural log of x. It'll get more complicated. We'll take the natural log of some other function. That's what you want to know. U prime over u. And this is where I'm saying don't overthink this. There's pretty much 3 steps here. One step is to identify what u is. The second step is to take the derivative. The third step is to put it together as u prime over u. As we work through natural log problems, I'm going to continue to say that over and over again. What's the derivative of the natural log? U prime over u, u prime over u, u prime over u, until it eventually burns into your brain. Question?
This is like, I don't know, I thought this, but would it be cheating if like you got a tattoo of like a problem, like a solution, like a equation? Like,
it depends on where you put it.
Like your arm.
Your arm would be cheating.
Really?
Like I have the distance formula across my back, like right up here.
No way.
And so that's okay because I can't see, and they won't let me take tests with it here. You guys, most of you are seniors. Was Miss Manch still here when you were freshmen? She was this little old woman. She's about 4'10". She was tiny. She had the loudest voice in the world. She was about as straight-laced as you can get, and we taught calc together. And so I would always tell my students that she had a math tattoo, and she would get infuriated with me because people would stop her and say, "Can I see your tattoo?" I said, "What are you talking about?" "Mr. Reedy said you have the blah, blah, blah formula on your shoulder." So I would continue to tell people that. No, I don't have the distance formula. I did a good tramp stamp.
Oh, yeah.
Yeah, but then you take a test, you keep doing this. So to answer your question, you probably have to cover it up. They would just staple paper to your form. It's hard to work. Okay, let's try that. Whoops. What's U? No, not Not Y-O-U, just you.
You, I am you. I am you.
What?
I am you. No, I am me. No, not you, me.
No,
He
I
is
am
you. I am you. Guess the movie.
I don't know.
Oh my.
I'm usually better at this.
Rush Hour. Rush? You've never seen it?
I've seen it once and then forgot about it.
That's why. No, I am fine. No, you.
Yeah, it's like going to Cleveland. You know, as soon as you leave, you just forget about it. Sorry, what's U?
2x.
What's U prime?
2
Therefore, the derivative of that would be
at 1 over x.
1 over x. 2 over 2x, which would simplify to 1 over x. Yes, simplify.
Over 2x.
Easy, yes? Beautiful. Parts B. What's U? X squared plus 1, what's U prime? 2x. Therefore, the derivative is 2x over x squared plus 1. Then you cancel an x, right? Yeah? I just get right there and then now I cancel the x's, right? No?
Yeah.
Yeah. Cancel those x's. No.
Oh,
I was just kidding. Don't cancel those x's. That's the final answer. Okay, how could we make this more interesting?
no. Exponents.
Got exponents. A trig would be a good way. Any others?
Negative.
Blindfold.
Negatives. Blindfold would be very interesting.
Bird box.
Bird box that one.
Better idea. How many cars are there?
Exactly. I heard two.
Hey, how about we do a little product rule? Derivative of x times the natural log of x is a product. So therefore, it's the first times the derivative of the second plus the second times the derivative of the first. The derivative of the natural log is 1 over x, the derivative of x is 1, so when you simplify it, you get it down to, whoops, 1 plus n over x. Easy peasy. Just wanted you to make sure that you recognize that as a product rule.
What's going on?
We're going to save trig for the end. Ooh, chain rule. Bring the 3 down, reduce it by 1, chain on the derivative of the stuff inside, we end up with that beast. And we're good to go. X's do not cancel again, because it's attached to the natural log. And there's a squared there. Make sure you're careful when working with the natural log to include parentheses and or brackets in the same place, in the correct place. Notice there's a difference between, in that last line on that slide, of the natural log of x quantity squared versus the natural log of x squared. They're different things. The question is, what's being squared, and how do I denote the proper thing being squared? Good? No? Come on. Okay, sorry. Let me rephrase my question. Are you caught up on this slide? I don't really care about your mental well-being. No? So no, you're not caught up, or no, you're not?
No.
Oh, both. Okay, good. I'll wait then. I understand.
Oh, you gotta change it now.
Okay, so what happens when we want to take the derivative of big, ugly, scary equations, or functions, I should say? Sometimes it's just a matter of grinding them out. However, I want to show you a new technique to use when taking derivatives. So as you see on the slide, it's just another weapon to add to your derivative arsenal, or your calculus arsenal.
Here's the battery.
Yeah, I can name most of those. There's a couple I can't do. I don't know what the black shield is.
What about the one on the right of the backpack and the shield?
On the right of the backpack and the shield.
Is that a backpack?
The sword. What's the sword in the bottom left?
This one? That's Cloud Sword from Final Fantasy VII. I don't know this one.
Bottom left,
Bottom left.
with the eye.
Oh, other left. That's from Soul Calibur.
You'll 100% know that.
I don't know that sword, I don't know that gun, and I don't know that black shield.
The gun to the right.
Oh, and I also don't know that gun. You got the lightsaber, good, yeah, very good. Very good. There's a lot of Mario Kart stuff in there.
Oh, yeah.
Ninja Turtles are over there on the right. Oh, I also don't know, anybody know what this tank is from? These are the Ninja Turtles. I know it, I know it's a movie, it's not from Marvel.
Oh, yeah, no, absolutely not.
Jacob. I'm sorry?
EMC 9000, is that in there?
I think that, now that you mention that, it might be one of these two.
One of the right is.
Yeah, that's a gravity, that might be the
Next to the.
Okay, great. So, if we look at that function, and I ask you to take the derivative of that function, hopefully you understand how much of a pain in the butt that would be. I've got a quotient rule, with a chain rule on the top, with a chain rule on the bottom. Wrap all that up together, it becomes a mess. So I have a different technique to solve that. And when I get done, you might say to yourself, well, that doesn't seem any easier. But I would argue that it actually is easier than using the traditional derivative method. Logarithmic differentiation has 3 steps to it. The first step is to take the natural log of both sides. Which again, rule of algebra, whatever you do to one side of the equation, you have to do to the other, and that's completely legitimate. Step number 2 is you're going to use your log properties and simplify the more complicated side of the equation. Then, take the derivative of both sides, because again, if you do something to one side, you got to do it to the other side. Step 3, solve for y prime, which will be your derivative. Seems pretty easy, right? Okay, before we move on, let me ask you this. What's the derivative, whoops, not h. What's the derivative of the natural log of smiley face? No. What's this? The derivative of the natural log of smiley face.
Smiley face prime over smiley face.
Smiley face prime over smiley face.
Is a prime smiley face like a real smiley face?
It's just the eyes showing and everything.
Yeah, it's the cheeky one.
Cheeky smile for the
Yeah, it is.
smiley face.
Yeah, uh-huh. Oh, boy. Okay, now, we're going to need that in a second. Step 1, take the natural log of both sides. That's easy, you just write an ln in front of both sides. Step 2, simplify. Which means I'm going to use all those log properties we talked about. The natural log of y is equal to. The natural log of a quotient is the natural log of the difference of the natural logs. Okay? Then we had an exponent rule, which allows me to bring that stuff out in front. Notice my parentheses there. The parentheses are very important because you need to denote that that's the natural log of x minus 2, not the natural log of x minus 2. Okay? Differentiate. What's the derivative of the natural log of y? Y prime over y. Good. That's why we did the smiley face thing. Right-hand side. What's the derivative of the natural log of x minus 2?
1 over x minus 2.
Beautiful. Which in this case would be 2 over x minus 2 because we had a 2 sitting out in front. 2's cancel here, yes?
No.
Okay, thought I could get somebody. What's the derivative of the natural log of x squared plus 1? What is it? What's u?
Oh, u is x squared plus 1.
X squared plus 1 goes on the bottom. What's u prime? 2x.
And then you gotta multiply across.
2's cancel. Okay, that's step 2. Step 3, solve for y prime. So I'm going to multiply both sides by y. Bring the y over here, put some brackets around this whole thing so I don't get confused. Those cancel. Beautiful. Oh, but wait. What's y equal to?
X minus 2 quantity squared over x squared plus 1.
Beautiful. So our final answer becomes 2 over x minus 2 minus x over x squared plus 1, all of that times x minus 2 quantity squared over the square root of x squared plus 1. For the most part, you don't need to simplify that. You can leave it like that. And you're saying to yourself, self, that's ridiculous. That's not easier. But it is. If you don't believe, hold on. If you don't believe me, then go and take the derivative of that puppy. Okay? 2 quick things. Listen quickly. If you have an absolute value, it doesn't matter when you take the derivative. Why? Because you can't take the natural log of a negative number. So when you turn it positive, it just becomes the regular thing. Okay? We're good. Trig, yeah, blah, 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 blah. Done. This one?
Yeah.
Okay. Homework's on the calendar. Have a good day, everybody.
Read back one more.
This one?
Yeah, please.
Mr. Brady,
Yo.
when I put this in my calculator and I run out error, that is what I got.
Right.
And
So
now I cannot figure out why.
what you can do, the easiest thing is this will only be in real
Thank you.
You steal my $20?
Yeah. Oh, yeah. That's good. About half of the people I do that with forget and they walk out. Yeah, they give me $20. Couldn't put one on you, Bocce. You're too good.
I know.
Why do you multiply by y?
Because our goal is to find what y prime is.
Okay.
So our last step is just to get that y out of there. So on the left-hand side, we just have y prime by
And
itself.
then y. Okay, so when you're okay, so then the x minus 2 squared over that is the y.
Right. This is not wrong, but it's more proper to get rid of the y instead of getting rid of the x. So all that is the original function that we started with.
Oh, okay, so you plug that in.
There you go.
And then it doesn't plug it.
You could, but who wants to do that? That would be painful.
Thank you.
Yep.
It's for fret or something.
Really? Oh, no.
So how many more chapters do we have until we start reviewing?
Like 2 at the most?
2.
2.5, something like that?
No.
Pretty manageable.
No.
Reedy. Reedy. You coming back? You coming back there, or are we going to our desk?
Cancer epidemiologists study the causes of all types of cancer, as well as the outcomes of those with disease. One of the first epidemiologic breakthroughs was in 1950, the discovery of the linkage between smoking and lung cancer by Sir Richard Dahl.
So, do the bacteria attack us water? I mean, what exactly is cardiovascular disease epidemiology?
Cardiovascular disease epidemiologists investigate diseases such as stroke and other heart troubles. They also study possible risk factors such as obesity and exercise. Did you know that childhood obesity has more than tripled in the last 30 years? This problem may be your challenge to investigate fairly soon.
So I guess the environmental epidemiology deals with all kinds of people might end up breathing.
Yes, when you're in your car, riding in traffic, or taking the bus or subway, you can thank an environmental or occupational epidemiologist for wondering how many pollutants your body is exposed to. Environmental and occupational epidemiologists study people who live and work in locations with potential disease-causing factors. For example, these scientists study workers in nuclear power plants, following these individuals over many years to see if they get different diseases from others in the population. These scientists then help to set the limits of safe exposure for all types of chemicals and pollutants, such as sulfur dioxide or nitrogen oxide, some elements in the exhaust from cars.
The injury epidemiologists strike me as odd because I thought they're dealing with an injury instead of disease-causing element.
In this case, we can define injury as damage to human tissue caused by exposure to energy far greater than our systems can handle. That energy might be chemical, electrical, mechanical, radiation, etc. If you ride a bicycle, you should wear a helmet. And if you ride a car, you need a seatbelt. Injury epidemiologists study topics such as automobile and bicycle safety. Their research gave us the evidence that showed we would be much safer with seatbelts than bicycles.
So, like injury epidemiologists, healthcare epidemiologists generally study hospitals and medical care.
They look for ways to improve quality of care and cost effectiveness of care. They also study large systems of health care provision such as Medicare, which is for senior citizens, and Medicaid for the poor.
We can guess what the infectious disease epidemiologists are up to. They study viruses and bacteria, such as influenza and E. coli 157.
They investigate outbreaks of disease, but also they investigate the progression of infectious disease over time, such as the resistance of malaria in certain parts of the world, and the drugs currently available to treat it.
What is pharmacoepidemiology?
Pharmacoepidemiologists study drugs and their effect on disease. They are often particularly interested in side effects that may be caused by drugs, which are illnesses that are sometimes caused by the drug being used to treat a patient. Reproductive epidemiologists study diseases that are related to pregnancy and childbirth, including genetic factors and birth defects.
So, what exactly do social epidemiologists do?
Social epidemiologists study the societal factors that impact population health, such as income inequality and neighborhood segregation. Where will you work as an epidemiologist? Will you be in a lab or in an office? If you are a clinical epidemiologist, as in healthcare or pharmacoepidemiology, you will work mainly with medical professionals in hospitals or clinics on ways to control the spread.
We completed our training at the Cosine Exploration Academy. We get some time off before we get our first real science assignment. We're all going to the state fair, right? We deserve a break from all that thinking about science. Look at this interview I just saw online with one of the officials from the state fair.
Listen, team, I don't know about you, but I'm done being scientific for now. I have to have fried butter at the fair this year. Huh? I think that's pretty fat. Know what I'm saying?
On some pretty cool fairs and noisy place. Let's hope it drowns out.
Dude, I can smell the food from over a mile away. How's that possible? I'm going to eat every behind. The fair's been open since, what, the 7th? That's fine, like, relax and have a little fun. Yeah, but don't tell Dr. Hertz about all of the food I'm going to eat. I'm headed towards the fried Twinkies.
Did you know a high school science teacher did an experiment? He put a Twinkie in his classroom to see what the shelf life was, and it lasted over 30 years. No decay, still, and it was so Earl
Yeah, like that's a compelling story. And I'm sure there's nothing, not even additives I can contribute. Wasn't even that good, my Earl.
This place is fantastic. I shot some great video of the fair and that other beautiful necklace. Thanks to match. I could shop here all day.
I could be here all day. Now that Norma made me swear off the fried stuff, I had to look elsewhere. And I found homemade pies, ice cream vendors, cotton candy, funnel cakes.
Earl, you're being sick. Please yourself. Check out. Artists. Isn't it amazing how they can turn sand into glass? Did you see the potters working the kilns? And I love watching how they stain furniture. Hey, I think I see Ivana. Hello. Can we go do something else? The crafts are nice, but the smell of chemicals and fuels is making me queasy.
Yeah, you're right. It doesn't smell that great here. Remember from the medical school lesson that we can take in chemicals from the environment to the respiratory system? And I think I've taken it plenty.
Let's go to the animal exhibits instead.
Yeah, right, Norma. I'm sure animal exhibits smell a lot better.
Hey, look! That guy won a yellow ribbon from some contest. What's that mean? Look at this poultry barn. There must be 1,000 birds in here. This is awesome. It smells in here like it is so unsanitary. And flies, they are everywhere. Look at how people are touching cages and trying to feed birds. Can't people read those signs that say to be careful? That is a pretty nasty sign with lots of warnings about diseases.
I'm not even sure what some of those diseases are. It's that dangerous that they need a sign like that. Man, we need a fly swatter in here.
All right, Chase. But before we go, I have to visit the petting zoo. Don't be wimps. I mean, you did make it through the academy, didn't you? After that, we can get something to eat and shop some more. See, everyone? Aren't the animals cute? Here is an Ovis aries. That's the scientific name for sheep. Oh, and look at the goats. Capra hircus is the scientific name for goats. And see all the kids having fun feeding the animals? Come on, guys, you have to admit, it's cute.
Well, the kids are cute, but look at the animals. They're licking off the food from the kids' fingers. That can't be good for the kids or the animals, if you ask me. I don't think that's all the animals are doing, Mo. I think I just stepped in something.
Hey, see that display over there? The local university is teaching kids about animals. Oh, people are holding the baby ducks and chicks. That is cute, isn't it, Ivana? I am sorry, Norma, but you will not We'd be glad to help. What can we do?
I'm Mr. Nash, director of the state fair. This entire operation is my responsibility, and I may have a big problem on my hands. We just got a call from the local health department. Apparently, 10 people, maybe more, have become ill. The health department doesn't know what caused it, and they are currently investigating. The department knows at least half of the people attending the fair, maybe all of them. But I don't know. Maybe it's just a coincidence that these people got sick. Maybe it has nothing to do with the fair. I asked the investigator if maybe the people didn't feel well after riding some of the rides, but she said that doesn't appear to be the case. Sir, we want to help. Would it be possible for us to talk to the victims and ask them some questions? I don't know if there's time. People come from all over the state to attend the fair. The health department is compiling information from those who've fallen ill over the phone. Maybe they will share something else that they have in common besides coming to the fair.
What happens if we haven't identified the illnesses?
If we can't figure out the source, we may have to close the fair. That would be a huge economic loss, as we're expecting about 700,000 people total the 12 days the fair is open. I'm really concerned that the media is going to find out, and then no one will want to come because they'll be afraid of getting sick. We obviously want people to be safe and have a good time. Can you help? My understanding is that you may have the scientific reasoning skills to help save the fair.
Wow. Dude, I think this is our medical mystery. The Academy has prepared us for this challenge. Let's get to it.
I know where to begin. Hey, Dee, do you still have the video you shot? Maybe there are clues in there. If we pay close attention to what we see in that video, maybe we'll find something useful.
Great idea, Bo. Here it is.
Hey guys, we've seen a lot of other things too. Remember the accident and the food vendors? And the fact that there are a lot of people here. It would be easy to have an illness here with all of the ways people could get sick. Oh, dude, I think I ate too much. What if I ate the wrong thing?
Now is the time to stay calm. You could cause yourself to get sick with a psychosomatic illness.
Students, can you hurry up and do something? The health department may let the media know what's going on, unless we can say we know what's causing the illnesses. Of course, I feel bad people
Huh?
What are you doing?
Watching
They changed the
Inactivity.
film?
From when? From last year, yes.
Oh, wow.
afraid to come to the fair, or worse yet, we may have to shut the fair down. I wouldn't be upset at all if you could write something, scientific sounding to, ease people's fears. I can't imagine it came from the fair anyway. Come on, just propose something scientific, and we'll announce it. Of course, Mr. Nash. We totally want to help. Plus, we've been all over the fairgrounds, so I'm sure we can speculate on what it can possibly be. It shouldn't be too difficult to guess. So there's no need for a big investigation that could take a long time to shut down the fair. Plus, I still haven't had a chance to ride some rides. Right! I knew I could count on you students. I like it. Quick!
So, oh my God, did you look at some of these tweets for Cody Parkey?
No.
Here, come here.
That's pretty good. I'll have to check this out when I get home.
Oh my God. Hey, come here for a second. You're a beer connoisseur, aren't you? Wait, Goose Island.
Yeah, like 312 LRH, I like their, they have a good tail. Yeah. Kick a field goal? They go down there, gotta kick it towards your, there's the line. They won't get many of that. You don't think so? You don't, well, okay. You don't think those are not gonna be killed? Yeah, do you think they'll actually get on You have a second math class? What are you guys
Hi, Tia, how are you? Living the dream, sister.
Like,